Hello everyone, I'm Aditya Singh and I'll be your instructor for this second week of Create classes. In this week, we are going to see how to get started with VBoards, get familiar with the interface of the VBoards, and also create our very own first project in VBoards. Okay, so I am using Ubuntu as my operating system and hopefully you all are using Windows as your operating system. So the only difference we are going to face initially is that when I type VBoards in the terminal, all you need to do is double click on the VBoards application in your Windows desktop or the directory where you have installed it. So before getting started, I would like to take this opportunity to show you all guys what you are going to be working for in the upcoming weeks in VBoards. So this is a line following and obstacle detecting bot. And if you guys can make it till the end of the create classes, by the end of it you guys will have your own working line following and obstacle detecting bot at least. So let's get started with the very basic. When you open VBoards, make sure that the simulations are not running. To check that the time is over there at the center top is 000. So let's begin by creating our own new world. To do that, go under the files and select new world. Okay, so welcome to our new world. It's pretty much empty right now, but it does has two nodes. World info, which is a node which has properties like gravity and friction and whatnot, just to add the real world effects and remove the ideal conditions or vice versa. So the gravity is by default 9.8 and we are going to leave it like that, and friction is null, so we are going to leave it like that for now. And let's move on to the next node, that is viewpoint. This node is pretty much has the properties that will affect the center of the screen, the black area, that is our viewpoint. And by changing the viewpoint we can bring various changes to our center screen, which is nothing but the view of our simulation. So with this we are done with our viewpoints node, and now we need to initialize a few more nodes. To do that we are going to go under the wizard section or tab and create a new project directory. Now I'm going to name this project as line follower. You can name it as you wish. So next, these are a few things that it's going to, few nodes that it's going to create. You can add a rectangular arena if you like. These are the directories where these WBT files and other things are going to be created. Once you finish this, it will take a little time, and then it will take a little more time, I guess. And then there it is. We have two more nodes, texture background and texture background light. So like all nodes, these have their own properties as well, and I believe we are not going to do a lot changes in those properties right now. Now what we are going to do next is add a new node. To do that you can click on the button plus sign over here, and then it creates an add a node which has base nodes and proto nodes. But before that, let me just show you all the buttons we have over here at the top. This is the hide the scene tree sidebar, so it hides the list of nodes over here. This is the add node button which will add nodes to your world, and then we have restore viewpoint button. Then to the right of it we have standard viewpoints, and it has front view, back view, left view, right view. If you are doing the engineering drawing, you'll get it what these are. Then we have open an existing world. Then there is a save current world. Then we have reload world. Once you reload the world, all the nodes will reinitialize and it will take a little more time. Then over here we have the simulation keys. Go backwards, play, pause, fast forward, super fast. Then over here we have some recording tools so that we can record our simulation of the world and show it or share it with our friends. So now back to adding a node to our world. So select texture background and then click on the add node button. Over there we have proto nodes and base nodes. Select proto nodes. Over there we have an object section. In the object section we have a list of items. Let's select for the basic, say, flow. So it's flows. We have 4 varieties of flows available. One is this, then this one, then this one, and then this one. Let's select this for now. So you can see on the left side we have rectangular arena added to our list of nodes, and on the center of the screen we have our flow visible to us because we have texture background light. If we didn't have that, we wouldn't be able to see anything because in our arena there is no light, there is total darkness. So make sure you have textured background light, which we added. I'd like to remind you that which we added by going under the section, under the tab wizards, and create a new project, and over there we included textured background and textured background light as well. So now we have these arrows which we can drag, translate our node rectangular arena, or else we can use the property translation under the node section and manually type the coordinates where we want to translate our node position, center position, or again we can drag it as you wish. It's up to you. Similar is true for rotation. We can either type the rotation or just rotate it by dragging the circular arrow that is available on all the X, Y, and Z axis. Now let's understand the mouse controls. We have left click, middle click, scroll, and right click. We can left click to left click on an object to just move our viewpoint with respect to that object. We can right click and move to just move with respect to our arena, and we can middle click and move the mouse to add rotation to our viewpoint. We can scroll in and scroll out for zoom in and zoom out as well. So you can always use drag to rotate the arena, or you can simply put the manual values in the rotation property of the rectangular arena node. It's up to you. Different situation demands different approaches. Next we have the name parameter, which is generally used in programming to call your node. Then after that we have contact material. We are going to leave that. Then we have floor size. By changing the floor size parameters, you can clearly understand what the floor size parameters basically are. And floor tile size changes the size of the tiles. That is it, what it does. Back to 0.5. Then we have full floor appearance, and in that we have type, that is checkered by default. You can set it to various options available in the form of a selection or drop down menu, whatever you call that. Then we have override color. We can always change the override color to just make things messier. So it's basically just up to you when to use it. I never use this, so I'm going to get back to the 111 white, that is. And then we have wall thickness, which you guys did right, changes the thickness of the wall. Now if I get minus, take the wall thickness to minus, you can see in the console at the bottom we have corresponding errors which says that the wall thickness should be positive. Then we have wall height over here. It is the same, that you can't have wall height as negative, and if you do so you'll get an error in the console. So you can always increase the height, that will ultimately increase the height of the wall. So let's leave it to it as it was by default, that is 0.1. Then we have wall appearance, color override, the same things that we had for the floor. Now we are pretty much done with the rectangular arena node. Now the next thing we are going to move on to is adding a different node to this arena. Yes, of course, now we are going to get back to our add node button. Over here we have base nodes and proto nodes. Earlier we tried proto nodes, let's now try base nodes. Over here we have a lot of options. Let's select solid for an instance. Let's add solid to our arena, and now you can see that there is a solid node added to the left section where in the list of nodes, but there is no visible solid over there in the arena. So something is happening that is quite not understandable at the moment. We'll get back to it. So we have over here a very special property in the solid node, that is children. Now in children node we get to add other nodes. So let's double click on the children property, and it opens add a node option. In the base node now we shall select shape, because the solid is missing what? Shape. Now once you add shape, under the shape we have appearance and geometry. Appearance is by default null, so, and geometry is by default null as well. So in geometry, let's add a box. We have different options available. You can add one of those if you want, but for now let's go with box. It's pretty standard. Add. Then we can see now there that our shape now has a geometry of a box. So now we need to add an appearance to it as well. So in the base node we have appearance, which will just add an appearance node which will has its own properties, which we can change to give different colors and all to our shape. So under the appearance, we'll go back to it later. So here we have is pickable. If we set is pickable to false, the draggable arrows vanish and we can no longer move the box by dragging it. So getting back to setting it to true. Now moving on, we have a lot of properties over here. May it be translation step, rotation step, but let's go through the famous ones. And bounding object is a pretty interesting property that a solid node has. So mind you that when we added a solid node to our world, we didn't have any physical appearance or visibility on our screen. We added shape to the children, and then we had the shape as cuboid, and thus we can see a cuboid at the center where the shape is placed. But actually, if you pass your robot through that shape in this world, it will pass right through that shape as if it was invisible to the bot, and as if it was a layer of air. So that means that we have added shape as a visibility, but it doesn't have any boundary. It doesn't have any solid appearance in the world, in this computer simulation world. So to do that, what we will do is change the bounding object from null to something else. In most cases, what we want is that if we can see a cuboid in the simulation world, we want it to be there as a solid. So the bounding object will be a shape, and it will be a replication of the shape added to the children of the solid. So I'm going to add shape to the bounding object, and now on clicking the drop down arrow, we have appearance set as null and geometry set as null. I'm going to change geometry to box and add appearance if necessary, or you can leave it. It is not going to affect. Anyways, let's add appearance to the standard appearance, and then we have physics set as null. Let's leave it to it for now. Then we have children, shape. Now in the bounding objects, in the geometry box, we need to open that section and set the size of the geometry of the box to be exact same as that of shape. We don't want the geometry of the bounding object to be greater than or smaller than the shape that is visible to the eyes on the viewpoint screen. So simulation screen, let's call it that. So what we can do is, in spite of adding manual shape to the bounding object, what we can do is call a reference to the shape. And now I'm going to show you how to do that. So first of all, I'm going to delete the bounding object shape. To do that, I select bounding object and press delete button. It is now set to null. Now I will go to children, shape, and when I click on shape, there is def, def. It is Python convention to name a function. I'm going to define it as my shape. Def stands for define. Now when I will click on bounding object, double click on bounding object, it will open the adder node, and I will now have an option under use named as my shape. I will add it to the bounding object, and now what it does is it just replicates all the properties of the shape, my shape that I named, and puts it to the bounding object. So now literally my shape is always equal to the bounding object. Now locked is false, so I can move it with the mouse. Lock is true. I can't move it by dragging with the mouse. Now I have physics as null, and now I'm going to add physics. What it's going to do is add physics to the object. That is, let's say I put an put the box in air and play the simulations. So what it will do is, if I select physics as null, the box will keep flying when the simulation is running. But if I add physics, let's say physics to the box, what it will do is, the moment I run the simulation, the physics will act on the box, and the physics involves gravity. So when I will run the simulation, the box will fall down on the ground. Keep your eyes on the screen. I'm changing the appearance properties of the shape, and which involves change in I've added material, texture, and texture transform as well. Under the geometry of box, we have the size parameter, which we can change to change the size of a cuboid. Let's make it 0.4 in the x direction. Now I have deleted the bounding object again, and now this time I'm going to show you how to add bounding object manually, not by calling it by defining the shape as my shape and then calling it. So I'm going to add by manually. So you can see in the center there is a square of visible. That is the only boundary that exists. Other than that, everything is air. Now I'm going to resize the bounding object such that it bounds the entire visible shape. So now the entire shape is bounded, and the vehicle or a bot will hit the object if it gets in the path and not just fly past it. So now we have a physics on, and now when I play the simulation, the box falls on the ground as expected. Now I'm going to increase my pace, and I hope you can keep up with it. So what I'm going to do is reduce the y coordinate so that it's flat, super flat, because we are now making a road. Now you can see that the bounding object is higher, or it has y axis y more than the desired uh, road. So what I'm going to do is definition my shape and add it to the bounding object. Under the use section, my shape, I'm going to use it. Now the bounding object completely aligns with the shape as well. So now this box is more or less going to act as a road for the line following bot. So I can always copy and paste any node. So I have copy pasted a node, and now I can move it in and place it in different places. So I have an L-shaped road right now. What I did is just copy pasted the node and changed the translation of the pasted node. Now on a short note, instead of going through the base node and changing a box into a super flat box and creating a road, you can always use protonodes. And in the protonodes, we already have under the objects an item named as road, and you can always use it to use as your road instead of going from scratch. So now I'm going to go under protonodes, under objects, and then there we have roads. There are different set of roads. Just pick any random node that suits our purpose. And then we have a protonode added to our list of nodes, straight road, segment, and there is nothing to explain any much over here, because I believe by now you can understand that whatever I am doing over here is nothing but just playing with the provided properties that the protonode road segment is providing us with. I can change the width and length of the road, remove the border of the road by setting it as false or true. Now we need to add another node, and this time it's going to be an obstacle. Either you can start with the scratch, add solid node and do something with it, or you can just delete that. And what you can do is copy paste the my road node, name is that obstacle, name it as obstacle, and then just change the geometry and change the y coordinate, Now don't make it super flat because it's not a road anymore. What you want to do is have a significant y coordinate so that it is a cuboid, and once you are done it will look something like this. You can always change the color of your shape by changing the diffusion color that is available under the children, under the shape, and then under the material section. So under the material you have diffusion color, you can change that. And with this we are pretty much done and through with the second week of Create classes. Hope you enjoyed it and learned something new, gained enough confidence to move on to the next week and perform very well in the coming tasks as well. I am always available on the Google Teams and all the WhatsApp groups as well. You know my name. If there is any doubt, feel free to contact me. And now it's finally time for us to depart. So bye bye and have a great day.